Now we are going to practice using the exponent rules that we just learned about. And so throughout the video, I would encourage you to pause the video, try the problems, then play the video back to check to see how you did. So I'd go ahead and pause now and try these three. Okay, so when you first look at these three, they look like they might be the same, but I can tell you they're not. And so for the first problem, the parentheses right here mean that this entire quantity, -5, should be squared. So this is -5 times -5, which makes this one +25. The second example, the negative is not in parentheses. And so order of operations says I need to first do 5 squared. I need to do my exponents. So this is like saying the opposite of 5 squared, or -1 times 5 squared. So 5 squared is 25, times -1 is -25. And the third one is using that new negative exponent rule. And so I first want to caution you, because it's a very common misunderstanding. A negative exponent does not make a negative number. So that negative exponent does not mean this is going to be -25. What it means is that you are going to have to move the base. So technically I could put this over 1 since it wasn't a fraction. I can make it a fraction. And so when you have a negative exponent, it needs to move either up or down, numerator to denominator, and make the exponent positive. So this 5 to the -2 needs to move to the denominator to become 5 to the +2. And the only thing that would be left in the top would be the 1. So in the numerator, I put the 1. So 1 over 5 squared is 1/25. Okay, so just a bit of advice. I would not worry like if you missed those. These are 3 very common mistakes. So if you missed 1, 2, 3 of them, I wouldn't feel bad. I wouldn't worry too much, because I purposely picked 3 things to start with that can confuse people. So moving on to the next example, I would again pause the video and try it out. Okay, so whenever you go to work this one, notice the entire quantity is in parentheses. So I would have that -1 exponent would belong with both the numerator and the denominator. So it's kind of like I'm distributing the exponent here to everything in parentheses. Okay, so now I have negative exponents, which tells me that my problem is not simplified. You should never have negative exponents in a final answer. So that needs to become a +1, so I need to move to the denominator to make my exponent positive. And this, again, I have a negative exponent, so the 5 will have to move to the numerator so that I can make that exponent positive. So now I have 5 to the 1, which is 5, over 1 to the first power, which is 1. So overall, I just get 5. Okay, next we have 3m to the -2, so I would pause, try it. When we look at this one, it's important to note that that 3 is not to the -2 power. This would mean that the -2 went with the 3. So 3 technically does have an exponent, and it's a 1. So what I do when I encounter problems with negative exponents is I go ahead and make it a fraction if it's not already. And I go through and I look at each piece and see if it needs to move or not. And what I mean by that is 3 has a positive exponent, so it can stay in the numerator. M has a negative exponent, so it will have to move, so I can make that m to the +2. So that is the simplified answer. So the next problem, different than the first because of the parentheses. So this time the parentheses tell us that that -2 exponent belongs to the 3 and to the m. So I get 3 to the -2, m to the -2. And there's understood multiplication right here. Since this is not a fraction, I'm going to go ahead and put it over 1 to make it look like a fraction, to make it a fraction. And then I go through and I look at each piece and see if it needs to move. Since the 3 has a negative exponent, It is not simplified. I make the exponent positive by moving the base. M has a negative exponent, so it will have to move to the denominator. Now, what's important here is that this is not the answer, just right here. Both of those are in the denominator, so I need to make it clear they're in the denominator by putting a 1 in the numerator. So notice I had it simplified here. 3 squared is 9, and this is the final answer. So the next problem, you can see the answer there. The next problem has several negative exponents, several zero exponents, kind of a lot going on. So what I would urge you to do is to just do a little bit at once. Don't try to figure out the final answer in one step. Do 2, 3, 4 steps. So you can even go through and write exponent right here if you want. So I'm going to look at one thing at a time and deal with everything at once. So 3 to the 1 has a positive exponent, so it will stay. X to the third, positive exponent, so again, x to the third can stay. Y to the negative 1, since you have a negative exponent, that will need to move to the denominator. Again, z to the negative 1, a negative exponent is not simplified. I need to move that to the denominator. So far I've looked at all these terms. Now I'm going to go to the denominator, and I'm going to start moving these things. So x to the negative 4, I have a negative exponent. That's not okay. So I'm going to need to move this to the numerator. So I would have x to the positive 4. I need positive exponents. And lastly, y to the 0, or anything to the 0, is just 1. So these two terms are really just 1 times 1, which is not necessary to write. So those two terms are just 1 times 1, which is just 1, which won't make a difference. So now I'm going to look over here and try to simplify more. So in the numerator, 3 to the 1 is just 3. X to the third times x to the fourth is x to the 7th. I'm using that product rule. In the denominator, I have y to the 1 times z to the 1. And I cannot combine anything any further. So that's it. That would be my simplified answer. And I am done. One way to know when you're simplified, if you have x's in multiple places or y's in multiple places, then you know that it's not simplified. That's not the case here, so I can move on. We'll try another one. For this one, every single thing that's in parentheses here, since this is a product, everything will have that 4 distributed to it. So that would give me the power to the power rule. I multiply the exponents here. So that gives me x to the negative 8 times x to the negative 12. If I were to make this a fraction and put it over 1, I can see that both things have a negative exponent, so both will have to move. So I would get x to the positive 8 and x to the positive 12 in the denominator. It's important that I keep a 1 up in the numerator to signify that this is in the denominator. So now I can use the product rule, add the exponents, and that gives me 1 over x to the 20th. So you might have solved that a different way and gotten the correct answers, and that is perfectly fine. You could have looked at the parentheses first and simplified this. So you could have noticed the product rule in the beginning and added the exponents to make that x to the negative 5 to the 4th to get x to the negative 20, and then to wind up at the same answer, and that's fine. So pausing this one, give this one a try. So this first part here, the power to a power rule gives me x to the negative 12. And then I'm going to just for now rewrite the rest times 2 x to the fourth. And then remember, when I have a number in front of a variable like that, it's implied multiplication, so I'm just going to rewrite that. So right now I have x to the negative 12 times 2 times x to the fourth. And if I make this a fraction by putting it all over 1, and I try to do one thing at a time, that's what I find most helpful. So x to the negative 12, I have a negative exponent. That's not okay. It needs to move to the denominator to become x to the positive 12. 2 has a positive exponent, 2 to the 1. That understood, so I'm going to rewrite it, but keep it in the numerator. X to the fourth has a positive exponent. It gets to stay. So when you're simplifying here, you might try to use the quotient rule, and that's okay. That says when you're dividing, you subtract the exponents. So if I were to subtract the exponents, I would get x to the negative 8, and then I would have to move it. So what I do here that I find a little easier is just to think about it. If I were to write this out, x times x times x times x 4 times, and then I were to write this out, x times x times x times x, and so on, 12 times. If I were to start canceling out the x's, I would be left with 8 x's in the denominator, 8. X times itself 8 times. So this is 2 over x to the 8th. If you arrived at that answer in a slightly different way than I did, that is perfectly fine. Now this one, if you go ahead and pause it and think about it. So this one might look intimidating, but really the rules are the same as they have been. Multiplication, a product, the bases are the same. So I'm going to add the exponents, just like I would if it were whole numbers here. So I would take the 2/3 and I would add to it 1/5. And you might want to pause and try that. Good fraction review. And when you add fractions, remember you need a common denominator. I'm going to skip that step, let you do that. And then that's your answer. This time, notice we have a power to a power. And power to a power is when you multiply the exponents. So what I would need to do is multiply 2/3 times 1/5. And remember, when you multiply fractions, you just multiply straight across the numerator. 2 times 1 is 2. Straight across, 3 times 5 is 15. Okay. So the next problem, if you want to pause it. And again, notice the negative 1 is only with the n. There's no parentheses. So that 2 has an exponent. It is 1, not negative 1. So whenever I start doing this one, I'm going to first do n to the third to the third. That is a power to a power rule. I multiply the exponents and get n to the 9th. And then I'm going to, for now, just rewrite the rest. That is times 2 to the 1. And there's understood multiplication dot here, so I'm actually going to write it, times n to the negative 1. Since this is not written as a fraction, I'm going to write it as a fraction because I think it's helpful. And then I'm going to go through and look at each piece and move what needs to move and keep what needs to keep. What needs to stay, rather. So n to the 9th has a positive exponent. I keep it. 2 to the 1 is just 2. It's a positive exponent. I'm going to keep it. N to the negative 1 has a negative exponent, so I need to move it. So now when I look here, I have n to the 9th over n to the 1. So that quotient rule says I should subtract the exponents. So that would give me n to the 8th. The other way to think about it is if I were to multiply this out, n times n times n, 9 n's. Multiply n times itself 9 times. If I were to cancel out, I would have n to the 8th left in the numerator. Nothing left in the denominator. And remember, it's times 2. So I put the 2 in the front rather than over here because that's just the proper way to write things. Okay, another one to try. Pause. And again, there's usually different ways to do these problems, and they will all arrive at the correct answer. So first, I'm going to rewrite the x in the numerator and do a little bit at a time. So on the denominator, notice the parentheses means that every term in this product is going to be squared. So this is going to be 2 squared. And then my product rule here, my power of a product, says x to the 0 to the 2. And that says to multiply the exponents. So that gives me times x to the 0. So when I go through and look at one piece at a time, x to the first power, it's a positive exponent. I'll keep it where it's at. 2 squared is 4. And anything to the 0 is just 1. So this really says 2 times 1. Or sorry, not 2 times 1. 2 to the second times 1. Or 4 times 1, so it's just 4. So that is just x over 4, and it is simplified. Okay, try a couple more problems. So this one here, I distribute the -1 to every part of this product. So that gives me 2 to the -1 times m to the -2. I multiply the exponents. It's a power to a power. And the denominator says m squared. It's a positive exponent, so I keep it where it's at. So then if I were to go through and look at each part and rewrite, move things that need to move, keep things that need to stay. So 2 to the -1, a negative exponent, needs to be positive, so I have to move it to the denominator. M to the -2, I need to make that exponent positive, so I move it. And then this m squared had a positive exponent, so I'm going to keep it in the denominator. Now notice everything moved to the denominator, so this is not the answer. This needs to be made known that it's in the denominator, so I need to put a 1. And so that's not quite simplified. I'm almost there. 2 to the 1 is just 2, and m squared times m squared is m to the 4th. So here I have my final answer, 1 over 2m to the 4th. One last problem. You want to pause, try this one. When I distribute this exponent, this -4, I get 2 to the -4, x to the -4. And for now, I'm just rewriting the denominator. I'm not going to do too much at once. It gets too confusing. But I will go ahead on the x and write that it has an exponent, a 1. So there are multiple ways that you can arrive at the same answer. You might do it a little differently than I do, and that's fine. But what I'm going to do is I'm going to look at each part here and just start rewriting things, trying to simplify a little bit at once. So here's that 2 to the -4 needs a positive exponent. I move it. X to the -4 needs a positive exponent, so I move it. So I'm going to look at all 4 of these things, keep what needs to stay, and move what needs to move. So down here, x to the -1, I'm not supposed to have negative exponents, so that will need to move to the numerator to become x to the +1. And then the last term I haven't looked at, x to the 1, it had a positive exponent, so I keep it where it's at. So I keep saying there are multiple ways to arrive at the same answer. So if you didn't notice this right off the bat, that's fine, but x to the 1 over x to the 1 is just x over x. So that will cancel out. So all that's left in the numerator is that understood 1. I need to write it. 2 to the 4th It's not 8, be careful there. It is 2 times 2 times 2 times 2, which is 16. And then the x to the 4th. So it's 1 over 16x to the 4th. So remember, when you are simplifying these, you should never have a negative exponent in your final answer. And the variables should only appear once. You should not have like an x in one place and then an x in another place.